Morning, dear students. Now I want to discuss NEET 2025 question paper from 16th question to question number 30. First question, 16th question. Which one of the following compounds does not decolorize bromine water? Aniline, cyclohexane, phenol, and vinyl benzene. Styrene provided. So, does not decolorize bromine water. For decolorizing of bromine water, there is multiple bond. There should be required multiple bond, either double bond or triple bond. So first one, aniline provided. Aniline, when it undergoes a reaction with bromine water, 2,4,6 tribromo aniline formed, and its color white PPT. It is white PPT. Means bromine water decolorization takes place. So when aniline reacts with bromine water, 2,4,6 tribromo aniline formed, and its color white PPT. Then decolorization takes place. So it is wrong option. Now moving to second option, cyclohexane. So cyclohexane, there is no multiple bond, either double bond or triple bond is there, then it can decolorize the bromine water. But in cyclohexane, no double bond or no triple bond. That's why here bromine water decolorization not take place. So here, what is the right answer? Option 2 is right answer. What is the right answer? Option 2 is right answer. Now moving to phenol. Phenol with bromine water, 2,4,6 tribromophenol. It is also white PPT. Means bromine color decolorization takes place. And last one, vinyl benzene, styrene. So styrene reacts with bromine water, then here bromohydrin compound produced. Means color will be changed. Color will be changed. So due to presence of that carbon-carbon double bond, it can involve in reaction. One new compound is formed, means its color changed. So then which option is right answer? Option 2 is right answer. Now moving to next question. Match list 1 with list 2. Here list 1, Haber process, Walker oxidation, Wilkinson catalyst, Jaglanata catalyst. List 2, iron catalyst, palladium dichloride, and one rhodium complex given, and TiCl4 with trimethyl aluminum provided. So now Haber process, iron catalyst used. Haber's process, iron catalyst used. Walker oxidation, palladium dichloride used. So Wilkinson catalyst, triphenyl phosphine, rhodium chloride used. Jaglanata catalyst, titanium tetrachloride with trimethyl aluminum used. Jaglanata catalyst means for the preparation of high density polyethylene, we can use this catalyst. So now A is matched with 1, B is matched with 2, C is matched with 3, and D is matched with 4. Then which option is right answer? Option 4 is right answer. Option 4 is right answer. So A is matched with 1, B is matched with 2, C is matched with 3, D is matched with 4. Now moving to next question. Another matching. Process and name of vitamin and deficiency disease provided. Vitamin B12, vitamin D, vitamin B2, vitamin B6, and silicosis and convulsions, rickets, pernicious anemia. Now here I provided NCRT data. So I provided here NCRT data. So now first one, vitamin B12, it's a deficiency disease, vitamin B12. What is that? Pernicious anemia. Pernicious anemia. Red blood cells deficient in hemoglobin. Red blood cells deficient in hemoglobin. So vitamin B12 deficiency disease, pernicious anemia. Now A is matched with 4. Now vitamin D, you know, vitamin D rickets, vitamin D rickets. Here vitamin D rickets, bone deformities in children and osteomalacia in adults. So now vitamin D rickets. Now vitamin B2, vitamin B2, that is cirrhosis, deficiency disease, cirrhosis, and fissuring at corners of mouth and lips, digestive disorders, and burning sensitive of the skin. So vitamin B2 deficiency disease, cirrhosis, matched with 1. Now vitamin B6, vitamin B6 and deficiency disease, convulsions, convulsions. So rest of the option in list 2, convulsions. Then which option is right answer? Option 3 is right answer. Option 3 is right answer. Vitamin B12 pernicious anemia, vitamin D rickets, vitamin B2 cirrhosis, vitamin B6 that is convulsions. So option 3 is right answer. So please go through this list. You can get required information. This is NCERT data only. Now moving to next question. Given below are two statements. Ferromagnetism is considered as an extreme form of paramagnetism. That is statement 1. The number of unpaired electrons in a chromium 2 plus ion is same as that of neodymium 3 plus ion. So ferromagnetism is an extreme form of paramagnetism. So substance which are attracted very strongly in applied magnetic field are termed as ferromagnetic. The substance which is strongly attracted by applied external magnetic field, it is termed as ferromagnetic. So in fact ferromagnetism is an extreme form of paramagnetism. So that statement 1 is right. Now coming to statement 2, the number of unpaired electrons in chromium 2 plus, number of unpaired electrons in chromium 2 plus. So chromium atomic number 24, electronic configuration argon 3d5 4s1. Here chromium 2 plus, in chromium 2 plus how many electrons are there? In chromium 2 plus how many unpaired electrons are there? Single electrons in chromium 2 plus. So now chromium 2 plus means one electron left from 4s, one electron left from 3d subshell, means here 3d4 is there. 3d4 means how many unpaired electrons? 4 unpaired electrons. 4 unpaired electrons. Now moving to neodymium 3 plus. So I provided here one table from NCERT textbook from D and F block elements. So now neodymium, where is neodymium? This is atomic number 60. But of course in question also provided neodymium atomic number 60. So neodymium atomic number 60. And neodymium which state asking here? Neodymium plus 3 state asking. So neodymium plus 3 state electronic configuration 4f3. So actually neodymium atomic number 60 and electronic configuration 4f 4 6s 2, and neodymium plus 3 state, 2 electron from left from s orbital, 1 electron left from 4f subshell, means 4f3. Then in f subshell, how many unpaired electrons are there? 3 unpaired electrons are there. How many unpaired electrons are there? 3 unpaired electrons are there. F subshell 7 orbitals now. 1, 2, 3, 4, 5, 6, 7. So how many unpaired electrons? 3 unpaired electrons. So in chromium 2 plus 4 unpaired electrons. In neodymium 3 plus 3 unpaired electrons. Of course, in table also provided 3 unpaired electrons in plus 3 state. So that this statement is incorrect. Number of unpaired electrons in chromium 2 plus is not same as number of unpaired electrons in neodymium 3 plus. This statement is incorrect. So now statement 1 correct, statement 2 incorrect. So that which option is right answer? Option 1 is right answer. Option 1 is right answer. So 1 minute to statement 1 true, statement 2 false. Na? Statement 1 true, statement 2 false. Yes, option 4 is right answer. Now moving to next question. If the half-life for a first order reaction is 1 minute, then the time required for 99% completion of the reaction is closest to. Now first order kinetics formula, K equal to 2.303 by T log A naught by A naught minus X. Now here time required for 99% completion. Time asking T equal to 2.303 by K log A naught by A naught minus X. Now here actually what is asking? Time asking half-life given now. So half-life given. So we can write like half-life given now. In the place of K we can write 0.693 by T of. This formula we can use. So you know K equal to 0.693 by T of half-life formula. Both formulas related to first order kinetics. So now 2.303 by T log A naught by A naught minus X. So 0.693 by half-life 1 minute given. Half-life of first order reaction is. So 2.303 by T log. So initial we can take 100 minus, and how much completed here? 99.9 completed. 99.9% completed. You have to take initial 100. So 100 by 100 minus 99. X means how much amount completed or consumption in the reaction. So now 0.693, that is equal to 2.303 log 100 by 0.1. Now 0. Here by T is there na, 0.693, that is equal to 2.303 by T log 1000. It is log 1000, log 10 cube. So now here 0.693 is equal to, so 2.303 by T and 3 into log 10 base 10. So log 10 base 10 value 1, then T equal to and 6.909 by 0.693. Then we can write multiply and divide with 110. Then we can write 6.909 into 10 by, and here 6.93. So roughly we can cancel it. Roughly we can cancel it. Then what is the answer? 10. So 10 minute is the right answer. Okay, what is the answer? 10 minute. So which option is the right answer? Option 1 is right answer. Option 1 is right answer. Now moving to next question. The correct order of decreasing basic strength of the given amines is. The correct order of decreasing basic strength of given amine is benzene amine, ethanamine, N-methyl aniline, N-ethyl ethanamine. So here like given. So basic strength here observe N-ethyl ethanamine greater than ethanamine greater than N-methyl aniline greater than aniline. This is the order, correct order. Here remember one thing, aromatic amines are less basic in nature than aliphatic amines. Aromatic amines are less basic in nature than aliphatic amines. Here aniline, this is aromatic amine. Aniline is aromatic amine. This lone pair involved in resonancy like. This lone pair involved in resonancy like. Due to resonancy, lone pair availability is less. Lone pair availability is less because lone pair involved in resonancy. Then that lone pair availability is very less now, so it cannot donate to other species effectively. So its basic nature dropping. So coming to before compound N-methyl aniline. So here also lone pair involved in resonancy plus some effect, but at the same time here nitrogen attached to one alkyl group, one methyl group. This plus I group can increase electron density on nitrogen atom. So alkyl groups can show plus I effect. So electron donating nature effect. So methyl group can increase electron density on nitrogen now. So here also lone pair on nitrogen involved in resonancy like aniline, but at the same time methyl group can increase electron density on nitrogen. So that slightly electron density increases on nitrogen as compared to aniline. So that it has somewhat more basic in nature as compared to aniline. Now coming to first one and second one means N-ethyl ethanamine, ethanamine. N-ethyl ethanamine, ethanamine. Here both are aliphatic compounds. Both are aliphatic amines. Here no resonancy present. Here no resonancy present. This is the reason lone pair delocalization not occurring. So lone pair availability is more on nitrogen atom. Lone pair availability is more on nitrogen. So they can donate their lone pairs to other species. So they are more basic in nature. But coming to second compound, 1-ethyl group means 1 plus I group can increase electron density on nitrogen. But here 2 alkyl groups means 2 plus I groups can increase more electron density on nitrogen. So that as compared to second compound, first compound more alkyl groups, so more basic in nature. So this is also in aqueous medium. Actually this is in aqueous medium, actually basic nature in aqueous medium. But for example, if you think about vapor phase or gaseous phase, what is the basic nature order? Suppose aliphatic amines, tertiary amine greater than secondary amine greater than primary amine greater than ammonia. But in aqueous phase, if you observe here diethylamine, suppose the triethylamine given, so diethylamine only more basic in nature. Actually in aqueous phase we need to consider for getting basic strength, steric factor, electronic factor, hydrogen bonding, all these conditions we have to consider. So of course here pKb values also supported this solution. So here lower pKb means higher Kb. Higher Kb means stronger base. So which compound having lower pKb means higher Kb. Higher Kb means a stronger base. So here observe lower pKb 3, 3.29, 9.30, 9.38. So pKb increases, basic nature decreases. So here data also I provided from NCERT. Here NCERT data in aqueous phase. Okay, thank you for understanding this question. Moving to next question. Here match list 1 with list 2 list 1 with list 2, cobalt 2 plus, magnesium 2 plus, lead 2 plus, aluminum 3 plus ions, and group number in cation analysis, group 1, group 3, group 4, group 6. This is a qualitative analysis, practical related question. Here I provided a table. Table. Please observe this one. Here group 0 cation, ammonium plus cation, and first group cations, silver plus, Hg2 2 plus, lead 2 plus, and second year group cations, second B group cations, group third cations, group fourth, group fifth, group sixth cations I provided here. From this you can answer this table, this question. Cobalt 2 plus, it is group 4th cation, magnesium 2 plus group 6th cation, lead 2 plus group 1, and aluminum 3 plus group 3rd cations. Aluminum 3 plus group 3rd cations. Aluminum 3 plus group 3rd cations. Iron 3 plus, chromium 3 plus, aluminum 3 plus. Here aluminum 3 plus group 3rd cation. Then which option is right answer? Option 3 is right answer. Option 3 is right answer. So cobalt 2 plus is matched with group 4th, magnesium 2 plus is matched with group 6th, and lead 2 plus is matched with group 1, and aluminum 3 plus is matched with group 3. So which option is right answer? Option 3 is right answer. So this table very helpful to you. Group cations table. Now moving to next question. Moving to next question. Now phosphoric acid ionizes in 3 steps with their ionization constant values Ka1, Ka2 and Ka3 respectively. While K is the overall ionization constant, which of the following statements are true? Log K equal to log Ka1 plus log Ka2 plus log Ka3. H3PO4 is a stronger acid than H2PO4 minus and HPO4 2 minus. And third one, Ka1 is greater than Ka2 is greater than Ka3. And fourth one, D, Ka1 is equal to Ka2 plus Ka3 by 2. Choose the correct answer from the options given below. Here phosphoric acid or orthophosphoric acid, both are same. So now phosphoric acid, it is having 3 protons. So first ionization, second ionization, third ionization I provided here, and their Ka1, Ka2, Ka3 equilibrium constant values I provided. Then if you add all these three reactions, then we will get net equation H3PO4 giving rise to 3H plus plus PO4 3 minus. Then Ka equal to Ka1 into Ka8 into Ka3. Then all fractions if you multiply, you will get to Ka. This is the Ka. Okay, now apply logarithm on both sides. Log Ka equal to log Ka1 into Ka2 into Ka3. Then log A into B into C. We can write log A plus log B log C. Log A plus log B plus log C. Log Ka1 plus log Ka2 plus log Ka3. So then first one is right. Okay, A is right. Now moving to B. H3PO4 is a stronger acid than H2PO4 minus and HPO4 2 minus. No, this is also right, because first acid dissociation is greater than second acid dissociation, which is greater than third acid dissociation. So that is right. And see, Ka1 is greater than Ka8 is greater than Ka3. So here statement C supports statement B. Now Ka1, Ka2, Ka3 data here provided here. So it is also taken from NCERT textbook. Phosphoric acid. Here observe phosphoric acid. First acid dissociation constant, second, third. So first acid dissociation constant 7.5 into 10 power minus 3, and second one 6.2 into 10 power minus 8, 4.2 into 10 power minus 13, so that Ka1 is greater than Ka8 is greater than Ka3. So this is the reason first proton it quickly give, second proton slowly provided, third proton it is not giving effectively. So this is the reason here H3PO4 is a stronger acid than H2PO4 minus and HPO4 2 minus, we can say like. So next one, coming to D, Ka1 is equal to Ka3 plus Ka2 by 2. This is wrong. So you know, here Ka is equal to Ka1 into Ka2 into Ka3. So we can we can take this relation as correct. K equal to Ka1 into Ka2 into Ka3. So here C right, D wrong. Then which option is the right answer? A, B, C. Correct only. A, B, C correct only. So D wrong. D is incorrect relation. Okay, I hope understood the solution. Now moving to next question. This is the data you can observe. This is NCERT table only. Now moving to next question. Which of the following statements are true? Unlike gallium that has a very high melting point, Cesium has very low melting point. This is incorrect statement. This is incorrect statement because gallium, cesium have low melting points, then almost similar. Not gallium very high melting point, cesium very low melting point. That is wrong. Both have almost similar melting points. 303 Kelvin gallium, 302 Kelvin cesium. This is the wrong statement. On Pauling scale, the electronegativity values of nitrogen and chlorine are not same. So this is also incorrect statement. This is also incorrect statement. Here, once observe this NCERT table. I provided here NCERT table. Here, nitrogen and chlorine electronegativity values same. Nitrogen 3 and chlorine also 3. Similar electronegativities according to Pauling scale. So this is a wrong statement. So that's why every student you should focus on NCERT tables. NCERT tables are very important. Each and every NCERT in NCERT textbook, each and every table, on each and every table you should focus. Data you have to remember. So now statement B incorrect. Now coming to C. Argon, K plus, Cl minus, Ca2 plus and sulfide are all isoelectronic spaces. Yes, it is right. All are having isoelectronic, all are isoelectronic spaces. They are having 18 electrons. Now, the correct order of first ionization enthalpies of sodium, magnesium, aluminum and silicon is silicon greater than aluminum greater than magnesium greater than sodium. So this is incorrect. Actually, aluminum magnesium reversed. Aluminum magnesium reversed. So once observe here. Yeah. Once observe, I provided here. First ionization energy. Here, which period elements? Third period elements. Third period elements. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Across the period from left to right, radius decreases. Radius decreases means ionization energy increases. So sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, this is expected order. But this is wrong. But what is the actual order? Sodium is less than aluminum, is less than magnesium, is less than silicon, is less than sulfur, is less than phosphorus, is less than chlorine. This is actual correct. Why? Here magnesium, aluminum reversed. Phosphorus, sulfur reversed. Why magnesium having higher first ionization energy than aluminum? Because in magnesium, in its valency shell, electron pair is there. So from pair, if you want to remove electron, second electron, that is a little bit difficult. In between them, more electrostatic attractions are there. Because they are opposite spinning, na? In between them, more electrostatic attractions are there. If you want to remove second electron from that pair, you need to give more energy. So that's why magnesium having greater ionization energy, first ionization energy as compared to aluminum. because in aluminum it's in its valence shell single electron is there, now we can remove easily. Now moving to phosphorus sulfur, same reversed. Here phosphorus having greater ionization energy, first ionization energy as compared to sulfur, because here phosphorus off filled electrons are there. Off filled electrons are there. You know, off filled completely filled orbital containing atoms are more stable due to exchange energy. So 3 ampere electrons, here 2 ampere electrons as compared to 2 ampere electrons. So 3 ampere electrons more exchange energy. So during the exchange of electrons more energy liberated, so more stability gaining. This is the reason as compared to sulfur, phosphorus having more ionization energy, required more ionization energy. So this is the reason. So sodium is less than aluminum, is less than magnesium, is less than silicon, is less than sulfur, is less than phosphorus, is less than chlorine is the right answer. Same this third period elements order you can follow apply to second period elements also. Very very important it is. So that's why here statement D is incorrect, because here silicon, aluminum, magnesium given. This is wrong. Silicon greater than magnesium, greater than aluminum, greater than sodium is the right answer. Now the atomic radius of cesium is greater than that of lithium and rubidium. As compared to lithium and rubidium, cesium its radius is greater. So of course it is the right answer. It is the right statement. Now once observe solution. So first A group elements, these are lithium, sodium, potassium, rubidium, cesium. You know, as compared to cesium, lithium, rubidium, their radius is less. So cesium has greater radius than lithium and rubidium. So as compared to lithium and rubidium, cesium greater radius. So that which options, which statements are right? Statement C right, statement E right. So C and E only correct. C and E only right. So which one is right? Option 3 right. Which is right? Option 3 right. Now moving to next question. Given below are two statements. Like nitrogen that can form ammonia, arsenic can form arsine. Statement 2. Antimony cannot form antimony pentoxide. Now, like nitrogen that can form ammonia, arsenic can form arsine. So this statement is right. Statement is right. Antimony cannot form antimony pentoxide. This is wrong. So now here all the elements of group 15th, form hydrides of EH3 type. Here is group 15th atom. So nitrogen can form ammonia, arsenic can form arsine, ASH3. All the elements of group 15th form two types of oxides, E2O3 and E2O5. Antimony forms antimony pentoxide. That is right. It can form actually antimony pentoxide, Sb2O5, but here cannot form given. So statement 1 correct, statement 2 incorrect. Statement 1 correct, statement 2 incorrect. Then which option is right answer? Here option 4 is right answer. Now moving to next question. Which of the following aqueous solution will exhibit highest boiling point? 0.015 molar glucose, 0.01 molar urea, 0.01 molar KNO3, 0.01 molar sodium sulfate. Now here highest boiling point. You know, elevation and boiling point formula, delta TB equal to Kb into molality into Vanta factor. And delta TB directly proportional to molality into Vanta factor. Concentration into Vanta factor. You know, delta TB and boiling point, elevation and boiling point to boiling point of solution. Both are directly proportional to C into I. So C means concentration, molality into Vanta factor. So glucose non-electrolyte, it's want of factor 1. So 0.015 into 1, 0.015, and 0.01 molar urea. So 0.01 into urea want of factor 1. So 0.01, and KNO3, K plus NO3 minus. So 0.01 into 2, 0.02, and Na2SO4, its want of factor 3. How it ionized? How it ionized to Na plus SO4 2 minus. How many ions? So 3 ions. Here KNO3, K plus NO3 minus. How many ions? 2 ions. Urea non-electrolyte, want of factor 1. Glucose want of factor 1, non-electrolyte. So that here highest boiling point means which has greater value, which has greater value, Na2SO4, Na2SO4 0.03, it is greater value, so it has highest boiling point. So option 4 is right answer. Option 4 is right answer. I hope understood the solution. Very simple. Boiling point of solution is directly proportional to C into I. C into I. Now, given below are two statements. First statement, benzene diazoxime salt is prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. It decomposes easily in dry state. So this is the right statement. Cold condition, benzene diazoxime chloride is more stable. On heating, it can easily decompose. So here statement 1 is right. Now coming to statement 2, insertion of iodine into the benzene ring is difficult, and hence iodobenzene is prepared through the reaction of benzene diazoxime salt with potassium iodide. Just we can introduce with potassium iodide that benzene and diazoxime chloride will be converted into iodobenzene. So that statement 2 also right. Statement 2 also right. So here both statements are right. Both statements are correct. So both statements are correct. It's option 2 is right answer. So how can we prepare iodobenzene? By introducing directly with potassium iodide, benzene diazoxime chloride will be converted into iodobenzene. So both statements are right. So now moving to next question. Identify the suitable reagent for the following conversion. Here methyl benzoate convert into benzaldehyde. So which reagent is suitable? Correct. Which reagent is perfect? First one, Lindlar's catalyst given. So it is not perfect reagent. So Lindlar's catalyst, what do they use? Acid halides convert into aldehydes. Suppose benzoyl chloride converted into benzaldehyde, not ester converted into aldehyde. Now coming to second reagent, lithium aluminum hydride. Suppose that ester treated with lithium aluminum hydride, it will turn into benzyl alcohol. So it is not correct. Diisobutyl aluminum hydride. What is this? Diisobutyl aluminum hydride it is. It is diisobutyl aluminum hydride, simply called dibol. Diisobutyl aluminum hydride, and here minus 78 degrees centigrade also provided, and second reagent is water. So diisobutyl aluminum hydride, then this ester converted into aldehyde. This is the suitable reagent. Last one, sodium borohydride. Sodium borohydride cannot reduce ester. Sodium borohydride can reduce only 4 functional groups. Sodium borohydride can reduce 4 functional groups. So it can reduce aldehyde into primary alcohol, and ketone into secondary alcohol, and alkyl halide into alkane, and acid halide converted into first aldehyde. Again that aldehyde converted into primary alcohol. Primary alcohol. Okay, primary alcohol. Understood? Primary alcohol. Primary alcohol. Primary alcohol. So sodium borohydride can reduce these four functional groups only: aldehyde into primary alcohol, ketone into secondary alcohol, alkali halide into alkane, acid halide into primary alcohol. So it can reduce these four functional groups only. It cannot reduce ester into primary alcohol. Of course, here ester, here given conversion ester to aldehyde. So then what is a perfect reagent? Dibol. Dibol. Here we can write a mechanism also. So dibol, it can provide hydride ion. Dibol, it can provide. So it can provide hydride ion. Hydride ion. So then ester, here ester is there na. So this ester or C double bond O CH3 Me. So now hydride ion, it can provide a hydride ion. So this hydride ion can involved in nucleophilic addition reaction initially. Nucleophilic addition reaction like then O minus OMe and hydrogen, unstable tetrahedron intermediate. Then again non-bonded electrons involved in pi bond formation. This is polar bond, easily breaking and removed as methoxide ion. Then what compound formed? Benzaldehyde. Benzaldehyde. Methoxide ion eliminated. Okay, this is the benzaldehyde. Okay, so dibol can convert methyl benzoate into benzaldehyde. So option 3 right answer. Now moving to next question. Given below are two statements. One is labeled as assertion and other one is labeled as reason. And one iodobutane undergoes SN2 reaction faster than 1-chlorobutane. This is the right statement only. So leaving group ability order, both SN1 and SN2, leaving group ability order, iodine good leaving group than bromine, which is good leaving group than chlorine, which is good leaving group than fluorine. So iodine very good leaving group. That's why its rate of reaction very faster. Iodine is very good leaving group. That's why its rate of reaction very faster in both SN1 and SN2 reaction. So 1-iodobutane undergoes SN2 reaction faster than 1-chlorobutane. This is right. Assertion right. Iodine is a better leaving group because of its large sizes. Exactly, perfect reason. Perfect reason. So now assertion, reason both are true. Reason is correct explanation for assertion. So that statement 2 is right answer. Statement 2 is right answer. Now moving to next question. The correct order of decreasing acidity of the following aliphatic acids is. The correct order of decreasing acidity of the following aliphatic acids is. Here I provided here formic acid is greater than acetic acid is greater than 2-methyl propanoic acid is greater than 2,2-dimethyl propanoic acid. This is the correct acidic nature order. This is the correct acidic nature order. So acidic nature order, acidic nature order. So this is correct order, acidic nature order. This is the correct acidic nature order. Reason, here reason, formic acid, hydrogen. In formic acid, hydrogen, neither donor nor acceptor. This is, we can treat it as some neutral compound. Now coming to acetic acid or ethanoic acid, one plus I group is there. Alkyl groups can act as plus I groups. This plus I group can increase electron density on carboxylic acid carbon. Obviously, OH bond is very strong. It won't leave H plus ion with more ease, so acidic nature dropping. Now coming to next compound, two alkyl groups are there, means two plus I groups. Then more density increases on adjacent carbon, obviously on carboxylic acid carbon, of course OH will be more and more strong. Now coming to this compound 2,2-dimethyl propanoic acid, how many plus I groups? 3 plus I groups. How many plus I groups? 3 plus I groups. 3 plus I groups can increases more electron density on carboxylic acid group. Then OH will be more and more and more strong. It won't leave easily. So that number of alkyl groups increases, number of plus I groups increases. Then electron density on carboxylic group increases, carboxylic acid group increases. So that acidic nature decreases. So plus I effect increases in carboxylic acid, then their acidic nature decreases. This is the reason methanoic acid means formic acid is greater than acetic acid or ethanoic acid greater than 2-methyl propanoic acid greater than 2,2-dimethyl propanoic acid. So that which option is right answer? Option 4 is right answer. Option 4 is right answer. Option 4 is right answer. So these are the questions today I want to discuss. Now we have effectively completed 16th question to 30 question. Now remaining questions, remaining 15 questions we will discuss in the next lecture, in the next video. Thank you. Thank you so much. I think everyone understood these all solutions. I hope these all solutions will be helpful to you. So NCERT data also I inserted with all these solutions. Wherever required, I inserted there. So you can go through these all solutions. You will get more knowledge. Thank you. Thank you so much.